Let's talk about the derivative of an important function. Let's consider the derivative of the natural log of the absolute value of x. First, let's consider what this graph looks like and ways of representing it. So recall that if you're looking at the graph of y equals to the absolute value of x, that looks sort of like a V. And this graph is sort of like the graph of two linear functions, a line on the left and the line on the right. These two pieces can be represented on the right as y equals to x, and on the left as y equal to negative x. So whenever we see the absolute value of x, we can think of it as a piecewise function. So the absolute value of x can be thought of as, on the left-hand side, when your x's are less than 0, as negative x, and on the right-hand side, when your x's are positive, as positive x. Also, to accommodate for that middle point, you can attach it to either this first representation or that second representation. We'll include it in the second representation with a little equal sign there. This will help us understand what the derivative of the natural log of the absolute value of x is. Now, let's differentiate the natural log of the absolute value of x. For this function, we can also think of it as a piecewise function using what we have learned above. So when thinking about the natural log of the absolute value of x, we can think of it as a piecewise function and consider how things will look like when your x's are negative and when your x's are positive. When your x's are negative, we said above that we can replace this absolute value of x with a negative x. So instead of having the natural log of the absolute value of x, we can replace that with simply negative x. When your x's are positive, we said that we can replace the absolute value of x with simply x. So we can write this as the natural log of x. Now, when taking the derivative of this natural log of the absolute value, we can take the derivative of these individual pieces. So the derivative with respect to x of the natural log of the absolute value of x is going to be this piecewise function. And when your x's are negative, we'll be using this definition. And the derivative of that natural log of negative x would simply be 1 over negative x times negative 1, using the chain rule. And when your x's are positive, the derivative of natural log of x would simply be 1 over x. Notice that negative 1 over x times negative 1 simplifies to 1 over x. So this is going to be equal to 1 over x, whether your x's are negative, and 1 over x when your x's are positive. Note that in this case, you don't care about what happens at 0 because the natural log is not defined at 0, so you wouldn't even be able to differentiate it there. But what we have said is whether your x's are negative or positive, the derivative is 1 over x. So the derivative with respect to x of the natural log of the absolute value of x is going to be 1 over x for x's that are positive or negative, or in particular, when your x's are not equal to 0. This is a very important conclusion that we'll be using later on when we start learning about integrals. So when you're talking about integrals, you'll be asking what function can you differentiate to get another function? And when you're asking what function can we differentiate to get 1 over x, the answer will not simply be natural log of x, but it will be natural log of absolute value of x.